Hello, welcome to Notes. Today we are going to look at Notes 4.02. Before I start about the rhombus and the square, which is on the next page, I would like to go back over all the rules of our parallelogram and rectangle. So if you didn't have this sheet before, I'd love you to go back to this front page. Here, these properties, remember, are our reasons for the proofs. We're going to be doing some proof writing next week on these quadrilaterals. So really knowing these statements is going to be important. So in a parallelogram, opposite sides, remember, are always parallel. Also, in a parallelogram, opposite sides are congruent. In a parallelogram, opposite angles, this angle A and this angle C, are going to be congruent. In a parallelogram, consecutive angles, A and B here. A is acute, B is obtuse. Those are going to be supplementary or equal to 180. Last but not least, in a parallelogram, the diagonals, A to C and B to D. Notice, those are not the same measure. It's a lot longer for me to connect these than it is this way. But they bisect each other. So they cut each other at midpoints. A little special case, if a quadrilateral has one set of opposite sides, both parallel and congruent, then it's a parallelogram. That's going to help us again a little bit more with the proof writing. Rectangles. A rectangle, remember, is a parallelogram. So all of these rules are true about the rectangle, plus two more. Now a rectangle has congruent angles. So there are four congruent right angles. And with these two corners, the A and C kind of flipped up and in, okay? So again, the parallelogram is kind of shifted, but when we stand it straight up, the diagonals become congruent. So in a rectangle, the diagonals now are congruent in measure. So from A to C and B to D would be the same measure. They're also bisected. So all four of these little segments, remember, are equal to each other. Okay. Today we're going to continue into the rhombus and into the square. One other thing I want to talk about the rectangle. With those right angles, remember we make right triangles. So we have that Pythagorean theorem kind of hidden within the rectangle. So in some cases we use a squared plus b squared equals c squared. Same is going to fall for the rhombus and the square because there's more perpendicular pieces. Okay. So what a rhombus is compared to the parallelogram is what happens with the parallelogram is if we shorten up that side AB and CD and make all four sides equal, it now becomes a rhombus. So in a rhombus, there are four congruent sides. So rhombus has all sides being congruent. And when that happens, when we pull this side in a little and make all four sides equal, these diagonals become perpendicular. So if I draw in this diagonal here from the bottom left to the top right, and I draw in the other diagonal, I don't know if you noticed, but they become nice right angles in there. Okay. And something else that happens is this diagonal is coming in and it's making really a nice isosceles triangle here. That's going to be congruent by HL congruence. Okay, do you guys see the right angle? This hypotenuse of this right triangle and this leg reflexive property. So what ends up happening is this angle and this angle would be equal, this angle and this angle would be equal. So in the rhombus, these diagonals will bisect the opposite angles. Okay, so that's another rule of the rhombus. So these three rules were added in here for the rhombus. So with those perpendicular diagonals, remember that Pythagorean theorem, if I kind of outline this right triangle here really good, that Pythagorean theorem happens. A squared plus b squared equals c squared, where the c is that side of the rhombus. Okay. A square is down here at the bottom. A square, I'm going to try to lift up my camera here, is all of these shapes kind of all put together. So all 10 of these rules is a square. So if I take that rhombus and I kind of stand its sides up, we get the square. So a square is a parallelogram rectangle with perpendicular sides, okay, and congruent diagonals. And it's also a rhombus where it has 4 equal sides. Diagonals will become perpendicular and bisect the angles. So in this beautiful square, we get the right angles because it's a rectangle. We get this diagonal and this diagonal to be equal because it's a rectangle. We get the diagonals are perpendicular because it's a rhombus. And it bisects the angles. So this 90-degree angle becomes 2 45-degree angles when that diagonal gets drawn in. Right? I know it's a little fuzzy. We're going to go back over that on the next side. So those are all your properties of the parallelogram, rectangle, rhombus, and square. So those are our parallelograms. So going back over here to the family tree, last time we talked about the parallelogram. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other. For the rectangle, all of those hold true, plus all angles are congruent or are equal to 90 degrees, and diagonals are congruent. Okay? So those are all the properties of our parallelogram and our rectangle. That was from Notes 401. Today we just added in the rhombus, that if I draw in one diagonal straight across to the left and this diagonal straight down, we happen to make right angles. Okay? Something I do want to highlight out there quick is that makes us also not just right angles, but right triangles. So our Pythagorean theorem, A, B, C, is one of the favorites the state exam loves to highlight with this rhombus. Because it doesn't typically seem like the Pythagorean theorem would be in a 4-sided figure, especially one that's slanted like this. So they really like to use that property on their state exam questions. So all sides of a rhombus, again, are congruent. So all 4 of these sides are equal. So this C matches this C, matches this C, matches this C. There's 4 really right triangles there. Diagonals meet at right angles. So diagonals are perpendicular to each other. And diagonals bisect the angles. So this angle here was 30 degrees as a whole angle. Okay? It does get broken into 2 teeny tiny 15-degree angles in there. So that's that last property kind of added in. The square down at the bottom of that family tree, it's a square and it has the number 10 next to it because these 3 facts plus these 2 plus these 5 are all true about the square. So kind of looking at the family tree, Papa Quadrilateral is up top. Any facts that are true about him are true about everything. So in reality, a square is technically a rectangle. Okay, if I'm down at the bottom of my family tree, I'm related to my mama and my papa. Okay, so I share all of their properties. So a square is a rhombus, and a square is a rectangle. However, is a rectangle always going to be a square? No, because it doesn't have its right sides, or I'm sorry, its equal sides necessarily. Is a parallelogram always going to be a square? No, because the square is at the bottom of the family tree. So we're going to talk about some of those relationships in the next class as well when we go over here to the trapezoid. This kite kind of is hanging out by itself. Kite properties, there are no equal sides. I'm sorry, that's a false fact. There are no parallel sides, I meant to say there. There are no parallel sides. Opposite angles, one pair of opposite angles are equal here and here. But if you've ever put a kite together, you have the cross beams that always need to be perpendicular. So diagonals are perpendicular for a kite. That's where the rhombus gets it from. So these rules get shared into the rhombus. But also what's true up here gets shared into the rhombus as well. So we have some dominant genes over here with the parallel sides that overrule the no parallel sides. So that's how these 2 shapes kind of come together to make that rhombus. And 2 pair of adjacent equal sides. So these sides are equal and those sides are equal. So what we could do there is prove this shape this triangle equal to this triangle, perhaps by side, reflexive side. So we're going to be doing some proofwriting again in the next few classes. So if you didn't have that first sheet, I did attach it today in your notes, but I am going to flip ahead to notes 4.02 and talk about the rhombus. The rhombus, again, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Those are the 5 facts of it being a parallelogram. So since it's a rhombus, those ideas are true, plus 3 more. In a rhombus, all sides are equal. I'm going to mark that on my picture. BC, AB, AD, and AC. CD would be equal. So AB is congruent to BC, congruent to CD, congruent to AD. Also, diagonals are perpendicular. So in this case, diagonal AC would be perpendicular to diagonal BD. Also, diagonals bisect opposite angles. So what that's saying is this diagonal coming into angle C here is cutting angle C into 2 equal angles. So if angle C, if I took a protractor and measured that, so if I put this protractor in and kind of attempted to measure this angle, it's appearing, I have it flipped around there, it appears to be about 70 degrees, is where B is kind of falling at. Again, sorry, there's some shadowing happening here. So angle C appears to be about 70 degrees. So if that angle is 70 degrees, it's cut into 2 35-degree angles. All right. And same thing about A. A is an opposite angle, so it measures 70 degrees. So it's bisected also into 2 35-degree angles. So we have 2 35s there and 2 35s here. Well, since consecutive angles are supplementary, if angle C is 70, angle D should measure about, and obtuse measure, 110. All right. So then angle D is 110 degrees, and it's bisected into 2 55-degree angles. Well, if I again outline this right triangle here, 35, 55, that middle angle does have to be 90. So if I had this 35-degree angle and this 55-degree angle, adds to 90 degrees, makes the third angle here 90 degrees. So those are some of the rules kind of coming into play with our rhombus. So it has 4 equal sides and diagonals are perpendicular. Those perpendicular diagonals indicate we're going to be using this Pythagorean theorem at some point. So looking here at a proof. So I told you we're going to be doing a little bit of proofwriting. I'm going to start off with one here. Rhombus, RHOB. Well, if I know it's a rhombus, I know it has 4 equal sides. I know its diagonals are perpendicular. I know its diagonals bisect each other. So let's decide how we're going to prove some triangles congruent. So triangle HSR, this one here. Why is that congruent to triangle HSO? Well, I'm seeing some side going on, right? We have a reflexive side down the middle. Diagonals bisect each other, so that's how I know RS and SO are congruent. So given that it's a rhombus, I'm going to go in and call these 2 sides, RH and HO, congruent. Because in a parallelogram, in a rhombus, all sides are congruent. Well, what else? We have that reflexive property marked down the middle. So I'm thinking side, side, side here to mark those two triangles congruent. So again, when I saw the fact that it was a rhombus, I started marking all the pieces I could kind of prove out congruent. So here we're going to have HS is congruent to HS, reflexive property. And the other set of sides, I have a triple dash on RS and a triple dash on OS. So I'm going to say that RS is congruent to OS. So now that I have my three sets of sides, it's fair to come in and write out my proof. So triangle HSR would be congruent to triangle HSO by side, side, side congruence. Now I have to backfill a reason here for number 4. Why was RS and SO congruent? Well, that's a diagonal. What do I know about the diagonals? The diagonals bisect each other. So that's going to be my reason here. In a rhombus, in a rhombus. Now, how I write this is specific. You need to have that fact here. In a rhombus, diagonals bisect each other. All right. So with these proofs, you really need a statement with a matching reason, and you need to have the reasons being complete. Please don't just tell me diagonals or midpoint or bisector, okay? You need a full and complete sentence there. That's at minimum what you need. Anything less than that is not full credit as an answer. So there's a proof. Again, we're going to come back to more proofs next week. I really would like to look at some algebraic examples. So number 1, ABCD is a rhombus. So I know all 4 sides are equal. If BA is 5x minus 11 and A to D is 6x subtract 18, find its perimeter. So remember, your perimeter is the sum of all sides. Well, since all sides are equal, we're going to take that 5x minus 11 equals 6x minus 18. Okay, so we're going to set those equal to each other because they are the sides. They're not angle measures, so we don't have that 180 idea here. If I subtract my 5x from both sides, add my 18 over, I should get that 7 equals x. But I'm not done yet. I need to sub 7 back in for each set of each side. So we could do the 5 times 7 minus 11, and we get that this side is 24. I'm going to mark it right on the picture. Well, 6 times 11 minus 18 is also going to give me, let's try putting in the right number, Miss Locke. 6 times 7 is my x value, minus 18 is also going to give me 24. Okay? So if each side is 24, we have to take 24 times 4 sides, should be 96. All right, so that perimeter of ABCD will be 96. Number 2, rhombus ABCD. And I purposely put this shape here because I know how hard it is to draw these rhombi. Plural of rhombus would be rhombi, but a rhombus, ABCD with diagonals AC and BD. So make sure as you are labeling your picture, ABCD, that the A and the C fall opposite each other, B and the D, and with it being a rhombus, those diagonals are perpendicular. They meet at a point E. If A to C is 10, the whole diagonal is 10. So if that measured 10 inches, 10 centimeters, 10 something, I know that this is 5 and this is 5. So if AC equals 10, then AE and EC are each going to be 5 because it's bisected. So I automatically put that on my picture. If BD, which is this other diagonal, now I'm noticing I put the small measure on the longer side of my picture. You really just have to take the picture for what it is. It's not going to be drawn to scale here. BD is 24. This definitely doesn't look longer. But if the whole diagonal BD is 24, then B to E is going to be 12, and so will E to D also be 12. Right? So we have 12 there and 12 there. What it's asking for is the perimeter. So I need to find the measure of each side. Well, here we have a right triangle. That right triangle has two sides, the side of 5 and the side of 12. We need to find its third side. But we also have a right triangle up here. It has a 12 and it has a 5. Right? So all 4 of those right triangles, I kind of redraw them for us, has a side of 5 and a side of 12. We need to find the third side, its hypotenuse. So here we're going to put in 5 squared plus 12 squared equals c squared. 25 adds to 144 to become 169 as c squared. Square root. 13 is each side. Okay. So therefore, our perimeter is going to be 13 times 4 equal sides, and we get 52 as its perimeter. Now it's not degrees, it's just 52 segments long, 52 inches, centimeters, something. Right? One more question, number 3. Looking here at number 3, given a rhombus ABCD below, the measure of angle B is 54 degrees. Find the measure of angle ACD. So if we trace ACD here, it's this opening here we're looking for. Okay. So what I'm going to do is I'm going to take this 54 and I'm going to put it in the triangle I know up here, 54. Now that shape, again, is a rhombus. Now if I just focus on that rhombus and try to pull out a triangle, this triangle, ADC here, has 2 equal sides, AD and DC, with this top angle being 54. So if I gave you an isosceles triangle and asked you to find one of its base angles, you'd be good to go. That's really what's happening here. So this angle and this angle are going to be equal because this triangle is isosceles. So 180, subtract the 54, gives us 126, divided by 2 is going to be 63 degrees. So angle ACD will be 63 there. If you need to pause and retry, you can. Number 4 is very similar. So rhombus math, M-A-T-H, with diagonals that meet at point X. So I'm going to start M, A, T, and H. These diagonals are perpendicular and meet at a point X. If angle MAX is 22, MAX is here. If max is 22, you just graduated high school by now. If MAX is 22, then this, notice I just kind of traced a Z here. Isn't that going to tell me that this angle down here is 22? Yeah. What else do I know? I know 90 degrees inside here. This is 90, this one's 90, this one's 90, and this one's 90. So if you focus on a couple of the facts we have, there's a few different ways to look at these triangles. We can find the missing angles here, or here, or here, or here, okay, by subtracting 90 and 22 from 180. So 180 minus 90 minus 22 more is really 90 minus 22. It's going to give us 68 degrees. So that third angle in that triangle is 68. Well, that gives me that one, and that gives me this one. What about these ones and these ones over here and here? Well, another fact we have to remember is that these diagonals bisect the angles. So that angle at H, if I kind of re-sketch it down off the paper, this angle at H has 2 pieces. These are each equal. So this 22 is going to repeat up here. And that 68 at M, again, this is bisecting the angle, is going to repeat in there. So these 68s are going to match at one of the big angles, and these 22s are going to match at A and H. So finding these angles, XAT is also going to be 22 degrees. AXM, well, AX anything is going to be 90 degrees because that angle at X, all four angles at X are 90. And AMX, well, both angles at M are 68 degrees. So that's it for notes on the rhombus. Moving over to the square. The square is a parallelogram, a rectangle, and a rhombus. It's at the bottom of the family tree. Okay, so we got to think about it in that fashion. So we have a parallelogram, rectangle, rhombus. And if we think up the family tree, if I just sketch quickly a little here down in the corner, a square is both a rhombus, a rectangle, and a parallelogram. Okay, so the parallelogram, actually I should be drawing the arrows all down the tree here. Parallelogram, rhombus, rectangle share all their rules about the square. So correct answers here. A square is a rectangle. Is that always true, sometimes true, or never true? A square is always a rectangle. It's its offspring. So that's always true. A parallelogram being a rhombus. Well, if a parallelogram has equal sides, then it's a rhombus, but otherwise it's just a parallelogram. So sometimes that's going to be true. A rhombus is a square. Is a rhombus always going to be a square? That's going down the tree. That's not always true. A square is a parallelogram. Is a square always going to be a parallelogram that's up its tree? That is true. So a square shares all the rules of the parallelogram plus some more. Okay? So those are just some phrases that are given. Here are a couple more questions to be trying. So looking at number 6, in the accompanying diagram, quadrilateral ABCD is a square. So they tell us it's a square. So I know it has 4 equal sides, 4 equal angles. With diagonal DB drawn, which of the statements are not true? Is AB congruent to BC? AB and BC are congruent because all sides are congruent. Is AD congruent to CB? Well, opposite sides are congruent, so that's true. Is DA perpendicular to AB? Yeah, it's a rectangle, so it has right angles. So I'm guessing it's going to be choice 4. Everything else has been true so far. AD and DB is the side and the diagonal. The diagonal has to be longer, so those can't be equal. In the accompanying diagram of CDEF, a square is a square with diagonal CE drawn. So again, it's a square, so we know all 4 sides are equal, and it has 4 right angles. Is CFE an isosceles triangle? CFE is going to be isosceles, yes, it has 2 equal sides. Is CFE a right triangle? Yes, because angle F is a right angle. Is CFE congruent to CDE? Well, side, yeah, those will be congruent. It can't be equilateral. Again, this diagonal here is going to be longer than either of their sides because a squared plus b squared has to equal c squared. You have to add 2 things together to equal something different. Number 8. The side of a square is 4. Find the length of the diagonal in simplest radical form. So we draw a square, we draw the diagonal, well, the other side of the square is going to be 4. Again, our Pythagorean theorem here, a squared plus b squared equals c squared, finds us the third side of that shape. So a squared is 4 squared, b squared is 4 squared, equals c squared. 16 plus 16 will equal us to 32, equals c squared. And then we take the square root of both sides. Square the 32. We have to reduce the radical. Becomes 16 twice is 4 radical 2. So again, that was it for the notes, all right? There weren't very many questions there about the square. And these questions that we just did about the rhombus, question number 2, it'll tell you, is one of the most favorited questions for me for quizzing, testing, and midterms. Okay, moving to our classwork for today. Classwork 402, I want you to try, for the most part, on your own. I will give you a few hints here. Please refer back to the notes, re-listen to the notes if you're confused or it went too fast for you. Underline words. When this says it's a rhombus, mark in the 4 equal sides, put in the perpendiculars to help yourself. That might help eliminate any of these choices as you go through them. So you really have to read through them, mark up your diagrams. It's going to be a help. If I see blank pictures and just questions circled, you're probably not going to get full credit on this. Okay. Knowing the rules of your shapes, try what you can for 1 through 6 here. Question number 7, draw a picture. Label the picture, quadrilateral, A, B, C, D. If these parts are equal and those parts are equal, then these diagonals must be something. And I kind of gave you a hint a little bit with the picture I drew there. On the back, at 8, again, it says parallelogram. Draw yourself a parallelogram. Same thing here with number 9. Each choice is a different shape. I would draw them out. Try to help yourself there. Number 11, I know a lot of students typically struggle with because they miss these 2 words here. M-I-N-T, M-I-N-T. The big shape is a rectangle, but M-P-K-T, M-P-K-T, this shape here is a square. So that 6 repeats itself all the way around. Should help. Number 12, I'm going to say see notes number 2. Okay, I just had to give you a little star on that one. But from our notes page, this exercise number 2 should help with number 12. Again, you're going to need a picture there. Good luck with classwork 402. We'll see you next time.